So good morning again, everybody. My name is Philip Leclerc, for folks who don't know me. I've worked on the disclosure avoidance system for the 2020 decennial census for, I think, about 5 years now, close to the beginning of the project. I've touched, I think, almost all aspects of it to more greater or lesser degrees. Before I get started here, there are two things that I think I want to say. The first is I want to thank a few people. So John, Michael Hawes, and Ryan Cummings are in the audience, as well as William Sexton, Robert Ashmead, and Dan Kiefer, who aren't here. Conversations with them have heavily influenced my thoughts on this, even when I disagree with them at the end of it sometimes. And so it's been very useful sort of maturing my thoughts on a lot of how this works. And the second is, not too dissimilarly to John, I have too many words and too much content on my slides and not enough minutes to talk about all of them, so I'm going to kind of selectively jump around and skip a fair bit. So first I want to give a quick overview, just to give a kind of a sense of how or what exactly it is I want to convey here. So the beginning of my talk is going to be kind of pessimistic. Hopefully this is still useful because I think it identifies things that maybe someone smarter than me can figure out a way to work around, or at the very least obstacles folks should be aware of. But my basic motivation here is that I think in practical DP environments, composition between products is often poor for the very basic reason that most products we publish are not DP and won't be DP soon. And at the end of the budgeting process, the global budget is usually quite large. These are significant challenges that I don't expect to change anytime soon. Following on this, my impression from the DP literature is that a study of the privacy guarantees interpretation, and especially how to take that interpretation or some interpretation of it, and explain to / work with a group of people who are frequently non-technical to make quantitative choices about parameter settings, feels like to me an area that's very much in its infancy. We have quite a number of ways of interpreting the privacy guarantee at this point, but it feels like there's a fairly large question mark about how you go from those interpretations to talking to a group of people and having them make quantitative choices. So I'm mostly going to talk about semantics today and attempt to identify a few things that I think might help to try to bridge that gap a little bit. But mostly I really just want to highlight it and say, look, this is a thing that I think we need some help on, and that would help statistical agencies in trying to adopt differentially private methods. And then at the very end of the talk, I'm going to quickly, very briefly switch gears and talk about some other issues that are more, I think, narrowly technical and that aren't specifically focused on semantics. Okay, so for the pessimism now, the series of challenges that I think are present and that aren't going to change soon. The first, and this is the one that I think probably, in my opinion anyway, has been one of the greatest challenges, is that important parties, both internally and externally to an agency, tend to operate with conflicting definitions of privacy. If you're really, really lucky, these conflicts are explicit and they'll tell you why they disagree with you. A lot more commonly, no one really knows what they mean by privacy, and this is all sort of implicit until you've had a long argument about it. And then some of the details come out. I've sort of littered a few quotes here to try and illustrate some of the range of ideas you might get from people about what they think privacy means and what a reasonable way of defining privacy is. The first here is from one of several studies commissioned from the Census Bureau by the Jason's group, a group of external scientists who reviewed our work on the disclosure avoidance system. This quote neatly captures their perspective. So they sort of argue that having reviewed Title 13 and the arguments that we had made about what we thought was the right way to interpret the privacy guarantee, that they think the right thing to look at as far as a measure of privacy loss is basically a comparison of what an attacker knows after a release is conducted to what they know before the release is conducted, how much inferential strength varies between those two. I have some issues with this, but it is a fairly common perspective, and it came up frequently in our internal discussions of this topic over the years. The second quote here is from two of our more outspoken demographers involved in this conversation, Steve Ruggles and David Van Riper, external to the Census Bureau. They were commenting specifically on the Census Bureau reconstruction re-identification tack that John talked quite a bit about. And I don't really have anywhere near the time to go into the details of what they did, but at a very high level, the basic idea here is that they fixed kind of a very particular set of knowledge and said, we're going to classify this as sort of safe knowledge, and then if random variation beyond this occurs, that's kind of anything you can infer beyond that, we will consider to be unsafe. This is also not terribly dissimilar to some of the pre-DP ways of thinking, I think, about what privacy means. Again, have some issues with it, but don't really have time to go into those here. The third here is Title 13, the primary law that governs and obligates Census to protect respondents' privacy. I am not a lawyer, and this is probably the most important part of my slides to emphasize that I can't speak for the Census Bureau or on its behalf. But in my personal opinion, Title 13 and most laws of this era are typically written with a fair amount of ambiguity in them. They leave quite a bit up to interpretation. Here, the critical term is what does it mean to be identified? And you'll see a lot of the arguments over whether or not we are consistent with our Title 13 obligation will sort of be framed around that word identification and what identification means. And then lastly, the fourth quote here is probably more familiar to the audience in this room. This is one of the typical sort of participation-based guarantees that are often articulated in the DP literature. So your participation shouldn't hurt you very much as long as the privacy loss budget is small. And as I said, similar points of view sort of came up throughout the lifetime of the DAS internally, but they're harder to quote because they're inside the Bureau and not outside of it. So I went with the ones that were easier to quote here. The second obstacle that I want to talk about is that many parts of the system in which DP mechanisms are built inside national statistical agencies are difficult to make compatible with DP. John actually touched on, I think, a number of interesting examples of this as well. A few more that I'd like to bring up there are some that I think kind of fall into neat technical mathematical problems. These are ones where I think the research community has a clear and sort of obvious path for trying to help. Edit and imputation and realistic sampling designs are good examples here. I'll touch on them a little bit again briefly at the end of the talk. There's also a lot that really isn't a research problem. There are just very strong research and skill constraints inside of national statistical agencies. I mean, really, I can only talk about my experience at Census, but what I can say is that when it comes to having a conversation about whether a particular product should move to DP or not, or should adopt DP as its primary SDL system, there tends to be a very limited group of people who feel comfortable describing the product at an algorithmic level sufficient for evaluating whether or not even something like global sensitivity is correctly calculated. And even if you can find those people, build the system, implement it, there tends to be a very small group of people who are comfortable talking about choice of parameter values at the end. It relates back to the semantics issue. And then lastly, there are issues that I think are more cultural and don't really have obvious technical solutions. So the example I constantly bring up both internally, well, really mostly internally, I suppose, and now externally, is the way quality assurance works at Census. So there are a bunch of different quality assurance processes, but the specific one I want to highlight here is that for the decennial census, and I think this has been common practice historically, after the disclosure avoidance system was run, there was sort of review of the output. And when I say review, I mean sort of manual, largely subjective review, kind of looking at it and comparing it to the original values to try and see, in spirit, was there a bug? Are any of these departures so dramatic that we think there might have been something miscoded in the original system? That being said, we don't have a nice a priori definition of what a bug is. And you can imagine that if someone saw a particularly flagrant issue that we decided wasn't a bug, it could create a really interesting conversation about what to do about that. That didn't happen. The only thing that came close to sort of a rerun of the system was that there was an issue with the ETL processes leading up before we even got to the privacy system, but that has no privacy implications, so that's okay. And I don't think any reasonable interpretation of the way the production run was conducted could look at it and say, oh, they abused this quality assurance thing to like tune the noise that came out of the algorithm so it's not actually following the intended distribution. But this is an interesting kind of hole where we don't really have a nice drop-in replacement for this kind of manual subjective review that doesn't have a priori pre-stated technical definitions for what its concerns are. And I don't quite know what to do about that, to be honest. I think this is kind of a cultural issue that may just have to change over time. Or we may have to grow to accept it. I'm going to jump to 4 before 3, so I'll just note that the key decision makers here are frequently non-technical, and this is actually almost by design. I don't often see this articulated in the external DP community very much, but at least at Census, a common sentiment is that one of the advantages of moving to a DP system is that we can try to move the decision making away from sort of the narrow group of specialists and technologists and mathematicians who are responsible for designing the system, and move those decisions to the group of people who are typically higher in the managerial chain and have sort of the authority and the breadth of view to try to make explicit trade-off choices between accuracy and privacy for important use cases and for important kinds of privacy vulnerabilities. But this also creates problems because this makes it even harder to explain how the semantics work when the folks you're talking to aren't going to be familiar with the technical ideas that you're accustomed to sort of dealing in. Jumping back up to 3, the key decision makers involved here tend to, in my experience, at the end of these processes, pick global privacy loss budgets currently that are large. It's hard to be too explicit here, but I don't think I've met many folks in the DP literature who wouldn't look at the overall budget and say, oh, that's really quite big. I also don't think this is going to change soon. I think budgets are going to be large for probably a period of decades in most survey and census products that you see DP deployments occur in. And the reason I think this is that in my experience sort of talking with and watching conversations with external users, expectations for data granularity and accuracy on small populations are really, really high right now. As a quick anecdotal example, in our recent demonstration data product release, and this is not at all unique to this particular discussion, but in the discussion of that product, one of the common concerns raised was that there were large percentage errors. So at the county level, I think was the example, folks were looking and saying, look, there's percentage errors between like 500% and 1,000%. This is crazy. We would typically then go break down into those subpopulations, try to figure out, well, what errors are we actually talking about here, and find that the base population was very small. Which wasn't a shock to us and was a good thing because it meant that the DP system was kind of working as we expected it to work. But I think it highlights kind of a fundamental tension here. When the base population is 1 to 5 and you're still sort of arguing about whether or not it becoming a 3 or a 7 or something is problematic, there's the tension is fairly fundamental. And the only way to, I think, really make much progress there isn't purely technical. It's to have that hard conversation about whether or not privacy or accuracy should be prioritized. And because I think that conversation will move only slowly, I think we sort of have to accept this as part of the landscape, at least for the medium term. I'll say, although privacy loss budgets are never, in my experience, small or very rarely small, even when they are small, there are a bunch of additional sources of information leakage that occur at statistical agencies. So in the case of the decennial census, there are additional products that have already been released and a bunch extra that will almost certainly be released in the future that use non-DP SDL mechanisms and are releasing from the same microdata source as the DAS itself performed its release from. They're limited in some ways. That gives us a little bit of ability to preserve some of the privacy guarantee, but they are occurring. In addition, even if those weren't occurring, ideally, we'd like, I think, to offer a privacy guarantee that reflects kind of aggregate risk from participation in all of our surveys and censuses, and isn't just like on a product-by-product basis, pretending the others don't exist. And almost all of those products are handled through non-DP SDL mechanisms. There are also, so this is by no means an exhaustive list of obstacles. John, I think, listed a few more. I sort of notably left invariants out of here, probably because I was tired of talking about them, but they are also another major obstacle that I don't think is going to go away anytime soon. And I'm mostly going to talk about how I think some of the ways in which I think the semantics literature is underdeveloped for dealing with these problems. I don't think semantics can deal with all of these problems, and I think that might be a little bit idealistic, but I think they touch on a lot of them, and there may be some specific ways in which the semantics literature could be improved to try to at least acknowledge that if these are going to be features of the landscape going forward, maybe there's a bit more we can say that acknowledges that, assumes it, and kind of moves forward given that. The only point on this slide I want to highlight is the second one, just to fix terms. What I mean when I say semantics is minimally technical interpretations expressing a privacy guarantee. I will say I don't consider the DP definition itself or the ZCDP definition itself, I don't consider them privacy guarantees or semantics in this sense. I think they're useful technical tools and intermediaries, but I think you need to do more if you want to get to the point where you can enable non-mathematical policymakers to indicate quantitative preferences to you about accuracy versus privacy. I'm going to talk, and this is a bit of a detour now before getting into, there'll be a little bit about ways in which I think semantics can be improved here, but just to give, I guess, a glimpse into how I at least think about semantics currently, I'm going to focus on two examples of semantics that have come up frequently in our discussions at Census. The two that we've frequently discussed have been posterior prior style semantics, usually with fairly arbitrary priors and limited prior assumptions. These are very similar to the sort of JSON articulation from a few slides ago, bounding how much an attacker can learn relative to what they knew before the data release occurred at all. I'm not really particularly fond of these. I think they have some severe issues, but they have come up a lot, and we've discussed them a lot internally. And then what I want to compare them to are causal, what I'll call causal posterior semantics. These maybe hopefully will sound somewhat familiar because they're just bounds on how much an attacker can learn after a data release has occurred in the real world, relative to how much the attacker could have learned if that data release had occurred in a world where some sort of private intervention was carried out or privatizing intervention was carried out. The reference person's record was removed, the data was replaced with some dummy data, that kind of thing. I usually think of the argument behind these semantics in a few steps. I imagine sort of defining a counterfactual world in which a private intervention took place to treat this person's data privately by removing it to the extent that is possible. The second part that I usually find is left implicit and not made explicit, but I like to say it out loud, which is this sort of means that inferences made in this counterfactual world about this person should be considered okay. or at the very least, they shouldn't be considered privacy violating. They may still be bad in some other sense, but talking about them as privacy violations is a bit difficult. And then, of course, the usual thing to do mathematically is prove some sort of theorem that bounds inference in the real world relative to inference in this nice private world, and you get your argument that, oh, okay, so that this is why we're saying that we're making some kind of privacy guarantee as long as the budget's small enough so that bound is reasonably tight. And then lastly, I want to comment on, so it is important, I think, to both to have this conversation at the record level. The intervention needs to occur at the record level. And if you're careful about this, you can kind of talk about it as as isolating inferences that are causally enabled by the presence of the person's data, or are causally enabled by their participation in the data set. I think this is a useful way to interpret it, and I found in conversations with folks internally that at least at the extremes of epsilon equals 0 and epsilon equals infinity, I can kind of convince them that this is a sensible way of talking about it. I'm not sure it gets as far as helping them make quantitative choices, but they do at least believe, usually at the end of many, many long conversations, that this is a reasonable way of defining what privacy means, and that you run into issues if you stray too far from it. I'm not going to talk about some of the alternative ways of formulating semantics, so there are some really nice ones in terms of type 1 and type 2 bounds in the area of hypothesis tests. The only subpoint I really want to highlight here is that something that's struck me frequently about the formulations in terms of Bayesian updating is that, well, they do Bayesian updating. This isn't a shock. This is okay for most purposes because typically this is one of the things we don't mention when we're translating for a non-technical audience, the nature of the privacy guarantee that we're trying to express. But I kind of don't like having these asterisks in the back of my head that say, well, okay, but we are assuming a particular model of sort of rational updating. It would be nice if we could move away from that and maybe have more general guarantees that hold even in the presence of non-rational updating. I've kind of gone back and forth as I've thought about this and whether I think this is easy or hard. I think probably the easiest case is if deviations from rationality are multiplicative in form. I think at that point in most proofs that you see of this kind, you're just kind of term by term replacing and there's not really anything complicated going on. I'm not totally sure what happens if you move away from that. The central difficulty in my mind seems to be an important ingredient in these semantics proofs is that the attacker is aware that the intervention has occurred and that the person's data has been removed or treated privately. But as Ryan, I think, actually pointed out to me in some private conversations, if the attacker knows that and you're allowing their updating strategy to be a function of which world you're in, they can just sort of do arbitrarily crazy things in the counterfactual world and do something else entirely when they're in the real world, which is not a particularly helpful kind of counterexample to run into. And then lastly, this is kind of a minor note, but I'll just point out that semantics results in the literature tend to be formulated, frequently they stop at the point of sort of inference between two neighboring databases. This is often a nice sort of mathematical form, and it's a convenient mathematical intermediary, but I've never had a conversation with a decision maker where I thought that was a useful starting point. Almost always, I think they need to be translated into something that sort of integrates out uncertainty over the rest of the database and focuses on inference about sort of a hypothetical target person before you can even begin to have that conversation. Sometimes this is easy. In other cases, this is harder than you would expect it would be at first. But this is almost always something that I look for when I'm trying to figure out how to use semantics. This I'm going to skip through a little bit quickly because I think hopefully a lot of this is fairly familiar. Folks have had these similar conversations externally. I don't want to get to some of the stuff in the later slides, but I will just say this is a parallel to some extent to the first slide about the quotes from external folks and their notions of privacy. I've also witnessed debates internally that sort of parallel that to some extent, and also a little bit in the DP literature. One of those debates that's come up recurrently is whether or not DP makes assumptions about between records dependence. And in my mind, so at the time I really wasn't quite sure what to make of this when I first saw it come up. I think what I've been convinced of since then is that these were actually discussions about the way in which you're defining privacy in the first place, which is to say that they're discussions about semantics. They're not discussions about DP as a definition in itself. And I bring this up mostly because confusion about this inside of a national statistical agency when you're adopting DP methods makes it complicated to have clear conversations about what kind of guarantee you're actually trying to provide. So it's sort of important to come to a common understanding of what exactly it is underpins something as fundamental as whether or not between records dependence is an issue for the privacy guarantee or not. And then I have a few of the things here I think are relatively non-controversial, or at least commonly said. So I think privacy is about your data, what can be achieved only if your data is available. These seem to me to be the things that you unambiguously sort of have private ownership of. I'm a lot less convinced that privacy is about what can be learned about you using other people's data. I view this as generalizable inference. I think there may be places where generalizable inference is not okay, and maybe there are some kinds of generalizable inference we would like to try to block, but I think it has to be discussed kind of as a separate category of information because it behaves so very differently. And I'll just say, so I guess the reason I really wanted to bring this up is In my view, outside of the mathematics of DP, which are beautiful and interesting, I think this is really the most important conceptual contribution of the DP literature. I think this kind of proposes a definition of privacy, which is something we never really, from what I can tell, had outside of just whatever my method does is what privacy is. It was a sort of a much more common operationalization of this idea prior to DP coming onto the scene. And in a very practical sense, this helps to short circuit and avoid arguments about what constitutes safe prior knowledge. And I'm not sure how often folks in the audience have had those conversations. I've had them more than a few times at the Bureau. And in my experience, they're usually the kinds of conversations that don't converge in finite time. You just sort of go in circles arguing about what should be okay to assume for the attacker to know. There is, I think, a detrimental side effect of this kind of approach to defining privacy. It complicates things a bit in conversations with especially non-technical, but also even technical stakeholders, in that it sort of means you always have to reference a hypothetical world. This slide I am, in fact, even though I said I was going to skip the last one quickly, I am, in fact, going to skip this one quickly. The idea here is just that common examples, like the smoking causes cancer example in the literature, and also a simple example that we put in one of our official handbooks that Census published. In both cases, I think a posterior prior reasoning, at least from arbitrary priors, maybe there's some way to salvage this if you start from a prior that knows the data generating process perfectly. But in these cases, posterior prior tends to give really weird intuitions about the kinds of things you have to protect. And I think you can avoid that if you adopt a semantics, and you should avoid that by choosing a semantics, a definition of privacy that doesn't make these examples look like things that you have to protect. And then this issue of between records dependence, we'll return back to it, because the way I frame most of my thinking about this is that a major distinction is between privacy semantics that sort of penalize you for having strong between records dependence, and privacy framework and privacy semantics that don't penalize you for that, and sort of consider between records dependence as the stuff that you're actually trying to preserve, because this is the information between people that's more general than an individual person. One of the things that I like to do in that spirit is take theorems that are pre-existing in the literature. So this is kind of a simple generalization of a pufferfish theorem that held only in the independent case. I just throw a very simple kind of like term by term bound, uniform bound here on a particular way of measuring the strength of dependence between the record Rk and the rest of the records R negative k. If that's bounded between L and U, then it's relatively easy to show that the usual bound of e to the negative epsilon, e to the epsilon in this case degrades based on how extreme the values of L and U are. And so L and U serve as very simple measures of how extreme dependence is. Those directly degrade this particular kind of semantics definition that you could adopt. This is, again, not my preferred semantics definition, but the important thing for me here is that if you are going to have this conversation, I don't think it's enough to stop at saying, well, we're just going to assume independence. I think that's too special a case. I don't think most conversations with decision makers or stakeholders are going to go very far if you insist that you have to make very strong assumptions in order to make any kind of privacy guarantee. There's also a bunch of, I think, questions that I at least don't know the answers to if you do take this approach. How do you pick L and U? Is there a way to empirically estimate them or like theoretically bound them under some reasonable assumptions? Do they behave decently under composition, or do they kind of like jump around wildly in a way that's not very well behaved? And can we make any further assumptions to control that if they do? Maybe most importantly, if extreme values of L and U really reflect that we're taking a lot of people's information to make inferences about a target person, is that really the kind of thing we want to do? Is that really the kind of information that we want to bound? I don't think so. And then lastly, and I mean, this is kind of a boilerplate question, but it will come back and be more important in a little bit. We usually want to ask, does this hold for other DP frameworks as well? One of the reasons we might want to ask, does this hold for other DP frameworks as well, has roots in a story from the decennial. So John mentioned that we had switched to ZCDP. That transition wasn't seamless. It was very helpful in some ways. So thinner tails were nice, better composition properties were nice. Once we argued and talked about it quite a lot, I think we all became convinced that the semantics of it were maybe even nicer actually than pure DP. But when we started, we sort of found that there weren't semantics to talk about in the first place. By which I mean, the very first thing that we considered doing was discussing ZDP sort of as bounds on divergences or as bounds on the moments of the privacy loss variable. But that's not really an understandable conversation you can have with a non-technical decision maker. It's just not going to work. So the first thing we attempted to do was convert to epsilon delta DP because we had some experience attempting to interpret those parameters and explain them to people. Then we ran into a technical problem that we hadn't anticipated was going to occur. So we found that we wanted to interpret delta as sort of a probabilistic bound on the likelihood that an epsilon corresponding to some threshold would be exceeded. And we found we couldn't do that. We couldn't find, if you just start from an epsilon delta DP mechanism, any correct proofs that that delta has this nice probabilistic interpretation. We did find if we started from a ZCDP mechanism instead, and we used particulars to some of the looser conversions to the epsilon delta curve, that we could preserve this nice probabilistic interpretation. But that under, in particular, some of the tighter conversions, we ran into problems where we A, couldn't guarantee the probabilistic interpretation, and B, ran into the sort of tails of the privacy loss random variable that we're sort of trying to bound here to get this nice interpretation. We found that they weren't, under this particular interpretation, the probabilistic delta wasn't post-processing invariant. So these are both severe problems that took us a while to fix, which basically means we took a significant amount of time off from trying to explain these semantics to the key decision makers, and instead trying to sort of fix these problems and make sure we had semantics that we felt confident about in the first place. Now, sometimes semantics do exist. There are quite a lot in the literature, depending on the particular DP definition that you're working with. This is a fairly speculative slide, but the key idea here is that even when you have semantics in hand, I don't think there's a well-understood way of taking those and helping a group of people make quantitative decisions. So I've sort of listed ways I think that we have attempted to do this in the past. So we have a little bit of experience internally trying to sort of follow this Alexandra Wood et al. Non-technical primer papers approach, where you build little vignettes and you try to posit sort of concrete risks, show how the DP assumption bounds those particular risks. Maybe this makes things feel a bit more concrete and helps people to reason about them a bit more. In my experience, I think there's still maybe too many moving parts here, and people still have trouble sort of getting quantitative intuition about it, but it seems like a reasonable way to sort of try to move forward. The fourth bullet point here is maybe me just sort of leaning into my own personal biases, but I come from, to some extent, a decision analytic background, and in decision analysis, it's pretty common to try to estimate utility functions by constructing a series of nicely formalized pairwise gambles. I wonder if something like this procedure couldn't be adapted to the case of DP. Maybe even more interesting proposal than any of these came up the other day in the communications breakout group. Ian was actually, I think, the one who mentioned it. So there are sort of willingness to pay experiments that you can run and that have been run to some extent using, I think, only randomized response right now in the experimental literature, like the sort of becoming a little bit like behavioral economics. I wonder whether or not you could calibrate someone's privacy preferences, privacy accuracy preferences, using a simpler mechanism like randomized response, and then somehow under suitable assumptions argue that you can transfer that over to parameter settings for a more complicated mechanism. It seems to me there are a lot of problems in making that transition and figuring out what you have to assume to make that transition, but that might be a valuable way to sort of avoid some of the need to spend too much time on the details of explaining the way the guarantee works. And then lastly, I have kind of a caveat rather than a question or a proposal. This caveat is just that in conversations internally, folks often, when they're struggling to understand or to explain the worst case guarantee, it's common to turn to example attacks, best case attacks, like the recon re-ID attack that we had conducted, and to view these as sort of more concrete, more understandable, easier to grok. I kind of want to caution that I actually don't think this is typically the case. In my experience, you run into many of the same issues if you don't at least ask yourself the basic question, for a particular measure of risk being proposed or inferential strength being proposed from this attack, how much worse would that inferential risk measure have been if we had taken a reference person's record and excluded it, or taken a reference person's record and replaced their data? And I think if you don't ask this question, it's really easy to propose attacks or ways of analyzing an attack that are misleading or can be easily misunderstood. And I think the literature actually has, I don't have ready examples of this, but I think in the literature this is actually quite common as well. There are lots of attacks in the literature that I look at and think, oh, well, okay, it's actually quite obvious that if I weren't participating in the data set, this isn't something you would be able to do very effectively. And so in those cases, I'm pretty convinced that it's a good example of an attack. But there are also lots of examples of attacks in the literature that aren't like that and instead sort of operationalize a privacy definition that's unclear. And I think almost always it would be nice if there were this culture of asking this question, but before we propose something as an example of a privacy attack. And then the last two things I want to say about the semantics here are first that because the global privacy loss budgets are large, it's somewhat problematic that most of the semantics in the literature, I think maybe actually all of them that I can think of, they're probably missing a few here, that they pretty much always focus on the global privacy loss budget, which is fine if it's small. If it's small, it has this lovely property that we don't have to, in a practical sense, think about pseudo-identifiers anymore, which is something I don't like thinking about, and I'm really glad to see the sort of the SDL literature move away from. I don't want to have to guess about which collection of variables is going to be the collection that's sort of likely to cause a major vulnerability. Unfortunately, budgets are large. Global budgets have tended to be quite large, and usually the worst case guarantees that you can express in terms of semantics are correspondingly slack to the point that when you translate them into English, people just kind of raise their eyebrows at you and wonder why you're telling them that's a thing that you think is important. Because of this, I think there are sort of two reactions you can have, maybe at the same time. One is you can say, well, we need to make the global privacy loss budget smaller, and that's great if we can, but like I said, I'm pessimistic about that happening soon. I think a second tack we can take is to give up a little bit on this nice pseudo-identifier or dodging of the pseudo-identifiers issue, and instead say, well, what if there are additional assumptions we can make? And specifically, I imagine within record dependence assumptions. Are there particular assumptions we can make about how parts of the record relate to other parts of the record that are sufficient for us to express privacy guarantees that depend only on portions of the global privacy loss budget rather than the overall budget? A practical example of this, and John alluded a little bit to this in his talk, is that in the redistricting data summary file release, the overall row was a rather large 2.63. I will also mention this 2.63 is going to get bigger. When we get to DHC, that's drawing from the same microdata file. When we get to detailed DHC, that's drawing from the same microdata file. When we get to the joint products, that's drawing from the same microdata file. So that row is going to get larger. And this is not even accounting for those state and US level releases I talked about that are happening through non-DP mechanisms. Although the overall row is large, we went to some pains to make sure that the block level row was quite small. Practically speaking, sort of like our intuition here is that this should typically make inferences about which block a person resides in within their block group more difficult than most other kinds of inferences they may want to make. And it would be nice if semantics could help us kind of capture and reason about this kind of nuance. And then the very last thing I want to say about semantics is that it's not terribly common, actually I don't think I've seen it at all in the literature, to try to optimize over the choice of counterfactual world. So the counterfactual world, in my view anyway, the only real property about it that matters is that it should be interpretable as perfectly private. It shouldn't depend on the reference person's data in a way that sort of pollutes it and makes them wonder if that world is one in which their information has been compromised. But that leaves a lot of room for possibly choosing counterfactual worlds that may have more or less tight bounds. And Dan Kiefer actually had a really clever idea for how to abuse this kind of flexibility. He proposed that we might instead consider the counterfactual world constructed by replacing the reference person's record in the actual world with a new record sampled from the attacker's posterior beliefs, sort of conditional on the remaining records. We call this operator p-sample. It's a relatively simple idea, and I think it really naturally reduces some of the bounds in these theorems in a way that's convenient. And it makes me wonder a bit, a question that I don't think has ever been explicitly asked before, is there some notion or some sense in which we can prove that there's an optimal counterfactual world? Can we prove that we've sort of picked the best possible one, subject to the constraint that the counterfactual world should be obviously private? This is a result that is kind of analogous to the result from earlier slides. There isn't a whole lot in here that we haven't talked about before, but the structure of the rough independence assumption is slightly different. So here we have that the probability of the first set of variables v1 is approximately conditionally independent of the rest of the variables v2 in this target person's record, given also the rest of the records in the database, where LU is quantifying the strength or the weakness of the strength of that dependence assumption. And the key thing here is that in the right-hand side, if L and U are close to 1, then we get a bound that depends only on epsilon1, which I'm saying is the budget that was sort of relevant to the v1 queries. So it's the budget that was spent on queries that have non-constant dependence on v1, on the variables in v1. That epsilon1 is traditionally or typically going to be assumed to be much smaller, so it might be like the block level row rather than the global row. And I think this kind of thing can be valuable because while it's obviously not as strong a privacy guarantee as is associated with the global privacy loss budget, it gives us at least a way of trying to be explicit with decision makers, and probably elaborations on this, of being explicit with decision makers about the kinds of assumptions they are implicitly making when they choose to focus on sort of portions of the privacy loss budget and not the overall privacy loss budget as the thing that they want to be small. And then there are very similar questions you can ask here, to some extent, unfortunately, as you could have asked in the between dependence case. Probably the most important of which is, does this hold for other kinds of frameworks, or is there a better way of formalizing this than the quick and simple way that I put it together in? I'm going to skip almost all of these points and just say this is really a slide about other products constantly being released through non-DP SDL mechanisms. This is constantly going on. It's going to continue to go on unless someone at a very high level decides that the privacy vulnerabilities in them are just so great that they're not going to release any of the 130 or so products that Census is responsible for releasing, which I don't think is going to happen anytime soon. We are in an environment sort of during transition where lots of products are released with non-DP at the same time that we're trying to transition a smaller set of products towards DP. That can complicate our ability to explain the nature of the final privacy guarantee and why it's kind of effective and helpful in order to transition one product over, even though we know a whole bunch of others still won't compose well with it. And so to the extent that there's anything further we can say about that, it would be helpful. I'll say in the Decennial Ceph's case, so in the disclosure avoidance systems case for the 2020 census, our solution's pretty limited and straightforward. We just focus on counterfactual worlds that don't change the tabulations associated with the other non-DP releases. And that's a very simple way of going about it, but it at least retains some of our ability to express a privacy guarantee. I'll also point out there is an error here. So I said do not change substate counts, that actually should be do not change state and US counts. And then finally, I'll go to things that aren't semantics. Some of these have come up previously, specifically imputation, edited imputation, and sampling methods. I think the overarching question I have here, so it's nice to be able to as I think work is currently focusing on, try to figure out whether or not there are simple ways we can adjust these methods that will improve their compatibility with DP, because they're currently not compatible with DP very well at all, and tend to degrade privacy either substantially or to the degree that the epsilon is or rho is infinite. But I think sort of the overarching question I have here is, if you had simultaneous control of both the edited imputation system and the sampling system and the DP algorithm you were designing, is there some way in which you could generate or design an optimal mechanism from that, holding important parameters of the other systems constant, or not constant, but constraining them? So if you had constraints on sort of the required statistical power and sampling budget, could we design all of these systems together in order to minimize the privacy loss budget we achieved? And you can switch which variable is the optimization variable and which variables are the constrained variables. But I think this is kind of a long-term project for trying to figure out how these three systems should behave with respect to one another. And then I have a suggestion / question that I think is maybe more likely to get a hard no than the idea of incorporating those sources of error, edited imputation and sampling, into the DP guarantee. So something that comes up, this is in this last bullet point, something that comes up pretty regularly in discussions with external stakeholders is they will point out things like, well, you have told us, Census Bureau, that this population's characteristics, that their data is worse. You've said maybe there's measurement error in them, maybe there's a whole bunch of non-response error, a bunch of people in this population just didn't reply. Maybe there's coverage error, you had trouble reaching a bunch of people in this population. And I'm not a survey total error person, so there are probably categories of error I'm not even aware of that aren't listed here. But the distinction here is that these kinds of error are not under our control. We don't have the ability to tell you exactly what their distributions are. We can guess about their distributions, and we can say, well, like scientifically, we can model them, and we think maybe they're approximately Gaussian or something. And then we would have possibly, in principle, the ability to claim that those are, like, in some empirical sense, part of the disclosure guarantee, maybe even part of the DP guarantee. When I've asked that question or pitched that idea to DP audiences in the past, the reaction was, I think, some combination of trying to hold their lunch in and like not walking out of the room immediately, which I can understand because it's concerning to try to express the privacy guarantee with respect to distributions you don't actually know. That being said, I don't think this is enough in having this conversation with our kinds of external stakeholders, because I think they still feel it's fundamentally unfair to already know that there is significantly extra error in one population, but still impose the same SDL sort of noise requirements for them. Which makes me think that if the answer is the no that I suspect, that what we really need here is sort of more clearer demonstrations of what kinds of vulnerabilities would be associated with attempting to incorporate these kinds of non-controlled error sources into the DP guarantee. What kinds of mistakes would we likely make? What kinds of vulnerabilities would you likely expose? And how concrete could you make an attack to show that this is not a good thing to do? And that's everything I wanted to cover. So thank you very much.